Hello guys. So this lab 8, actually this is the last lab in combinational logic. As I told you in today's lecture and also in last week, logic circuits can be combinational or it can be sequential. So this is the last one. Everything almost we had so far is combinational. So this is the last lab that's combinational. So in this lab, we're gonna design what we call a verifier circuit. So as you see here, look at the idea. So here, this is lab. This is experiment number 7. This is the last. This is the last circuit you made in lab number 7. Okay, last lab. And then I want to design a circuit here. We call it checker or verifier. You want to verify, you want to check. Okay. So what happens is, this is lab number 7. It has 4 inputs, A, B, C, D. Okay. It had only one output, G. Okay. This one verifier here, also it's going to have A, B, C, D as you see here, and it has G. And then this circuit should tell you if this circuit actually should verify or should it check this circuit here. Okay. It should tell you if this circuit is correct or not. Okay. How can you do that? Very simple. You have to try all possible cases here in ABC. So you have to exhaustive test it, ABCD here. And then every time here, this circuit should compare the input here to the output here and then tell you if this is correct or not. Okay, that's why you have to try all possible cases here. So try all possible cases. This circuit will check if the result here 0 or 1 is actually correct, or it has to be corresponding to this one. And then this one, we have an LED here. This is the output of this circuit Y. So in this lab, you need to design this circuit. So this circuit here is actually Y here is should be actually, so this LED has to, or the output here has to, I think, let me see here. I think the output has to be 1 if it is incorrect. So you need to turn this LED on when the input here is, when the output here is incorrect. So when this circuit does not produce a correct output, so you have to turn it on. Let me, I think that's what I told you here. It's not the other way. I think, yeah, you have to turn it on when it is incorrect. If it is correct, it should be 0. Okay, so as long as the LED is off, so that means output here is correct. Okay, so now how can you design this circuit here? This is a combinational circuit. So how you can design? So this circuit actually has 1, 2, 3, 4, 5 inputs as you see here, and it has 1 output here. Okay, for ABCD here, this should have all possible cases. All possible cases for it should have all possible cases for ABCD. Okay, and now for this one here, you can for this one here, the output here you have, when you need to create a truth table. In this truth table, these are the input A, B, C, D, and G. Okay, and the output is actually Y. All what you have to do here in the truth table is if this one is when it is true, so the output here has to be when it's true, the output here has to be 0. If it is false, output here has to be 1. So when you create the truth table, the way you have to create it is, you have here all possible cases for A, B, C, D, and for this one, anyway, you have to have all possible cases for A, B, C, D, and G. Okay, this is number 1. For A, B, C, D, you are going to have 2 values here for G, 0 and 1. So for every value for every input in ABCD, you are going to have two values here for G when you create the truth table. In one row, G is 0. In another row, G is 1. Okay. For Y, the corresponding Y, for sure, one of them should be 0, one of them should be 1. It depends on which one is correct. So you have to go to lab 7 and see for this input, when the input, for example, is 0, 0, 0, for example. Okay, so we're going to have two rows in the table. Okay, 4 zeros here, and then G is 0. Another row, you have here 4 zeros, and then G is 1. Okay, for Y, one of them should be 1, the other one should be 0, depending on if the correct output. So for the correct G, because you have two rows, G is 0 and 1. Okay, so for the correct value, either G or 1, you have to put 0 here in Y. Okay, otherwise, if it is wrong, you have to put 5. Okay. So again, the way this one has to work is, or the way it should work is, when you try all possible values here, if your circuit is correct, correct means for every input here, for every input value, so the LED is off. Okay, if it happens that for one input, okay, the output here was wrong, so in this case, this one can turn on. For sure, if your circuit is correct, that means this LED is going to be off all the time. Okay, so if you want to test it and see if it's going to work or not, so try to disconnect one cable here, do some little change here, so that it can produce some false results here. You got what I'm saying? So if your circuit here gives correct results all the time, so this one will be off all the time. Okay. So that's what I'm telling you here. So you have a function, we call it Y, that verifies the correct operation of the 4 input function. Okay. Now, so this function here, this function has 5 input, five variables or 5 inputs. In the lecture, you learn it up to 4 variables. I told you usually if it is more than 4 variables, we don't do it manually. Usually we use some computer programs, online tools, and so on. And that's what I want you to learn in this lab. Okay, so in this case, because it is 5, I'm not asking you to make, there is a way, by the way. So there is a way to do key maps and other algorithms, but I don't want to overcomplicate it. It's okay. I think most of the people, when they teach this course, they teach to students up to 4 variables. More than that, you need to go for computer programs. So in this case, or in this program, in this lab, you have 2 options. Either you can use a digital, there is a way in digital to do that, to do this simplification of the circuit here, or there are some online resources. So I give you, let me jump here. Yeah, so I give you this website here. There are maybe other websites. So in this website, you can click here on 5 variables, for example, and you can create the truth table here. You have A, B, C, D, and then instead it's called here E instead of G. Is that okay? And then you can select what is the output here. Okay, is the output 0 or 1, or don't care? X here is don't care. Once you do the selection for everything here, you can use, I think this is one of the approaches, most method. You can try this method. Okay, and then you just click submit. Very simple, very easy. For sure, you can use it for up to 7 variables. You can use 4 variables as we did before, 3 variables, and so on. But in our case here, we have 5 variables. So this is one way. The other way here, thanks to the TA Jonathan, I asked him to make like a very short tutorial. There is a way in digital, in the digital tool you have, to do the same thing like this one. Okay, so he gave me this file here. So here I'm explaining how can you do it. So once you create the truth table here, simplification will be done for you. Okay, so very simple. So all what you have to do actually so far is just to create truth table for this one. Okay, you have to select in the truth table for every one value here. You are gonna have 2 values for G, 0 and 1. For the correct value, you have to put 0, because if it is correct, I want to output 0. For the false value, I put 1. Okay, and then once you finish the truth table, you need to use one of these tools, this one or this one, in order to do simplification. Once you do simplification, you need to implement this circuit, and you already have this circuit from last time. Hopefully you did not it was not disconnected, because I told you last time, or in the lab, I told you please don't disconnect it, because we need in lab number 8. Unfortunately, if you disconnect it, that means you have to connect it again. Okay. This is the last part in lab 7. Okay. I think that's everything I'm explaining here. So yeah, here you need to use pattern. Yeah, because I just told you we need to exhaustive search. We need to try all possible keys here in the inputs here. Okay. So to do that, I'm giving you some tutorial here how to do it. By the way, these numbers in the when I first posted this lab, these numbers 15 or 12 and so on. So they are not correct because you are not gonna find 15, 12 or so. So I corrected it now 3, 2, 1, and I'm explaining to you how can you do it using Discovery Kit. This pattern generator, as we did before, this pattern generator is gonna be used as you did in the previous labs to exhaustive search the input, okay, or give you all possible values for the input, okay. Yeah, so here I'm explaining how you connect it, okay. Here, as I told you before, you need to click, there is a hyperlink here, you need to connect it to see how can you make this setting, room logics, okay. How can you add it to pattern generator to generate the different inputs, okay. Yeah. And I think that's it. That's a very easy lab. Okay, just that's it. And then after that, you can demonstrate it to the teacher. I forgot to add here. Yeah, I forgot to add the questions. Yeah, you have very easy question. Let me see here what questions we have. Yeah. So here, yeah, one question here. Do you think why this circuit? Why this circuit is important in your opinion? Especially if you are working in when you design in case of a teamwork, okay. For example, in capstone, when you do your capstone, okay, maybe one subgroup, okay, is gonna work in a circuit, in a certain circuit, and you want to make sure the circuit is correct. That's it. Okay, so that is why this one is really very important. So someone did something, set a circuit, and you want to make sure it's correct. Okay, so you can do this way. So here I'm asking if there is any incorrect operation. If so, what are some issues caused to this one? Okay. If there is no, okay. But if your circuit is correct from last time, you are not going to see any incorrect operations. That's why I'm telling you, if you want to, you can try, if it is correct, you can try it at the beginning, you find everything is okay, and then you can intentionally, you can make a mistake, you can make a wrong connection, and see how this will impact the outputs, okay. Yeah, I'm telling you here, I want the output should be high in case of wrong operations. That's what I told you. So if it is correct operation, it should be 0. That means the LED has to be off if it is correct. If it is false, so we need to turn the LED on. Okay. Thanks so much, guys. I think that's very easy lab. Okay. Thanks. Bye.